Imagine trying to watch Netflix on a laptop, connected to the internet, without Wi-Fi. Sounds impossible today, right? But less than 30 years ago, connecting to the internet meant running cables through your home, your office, and sometimes even across entire buildings. No smartphones, no smart TVs, no wireless gaming, no video calls from anywhere. Then Wi-Fi arrived. And over the next 2 decades, it evolved from a slow and unreliable technology into something capable of delivering tens of gigabits per second. But here's something most people don't know. Wi-Fi didn't suddenly become fast. Every generation was created to solve a specific problem. One generation fixed speed, another fixed range, another fixed congestion, and the latest generation is attempting to eliminate wireless bottlenecks entirely. So in this video, we're going through the complete history of Wi-Fi, from the very first wireless networks to the incredible power of Wi-Fi 7. And by the end, you'll finally understand what all those Wi-Fi numbers actually mean. Let's start at the beginning. Before Wi-Fi became a household name, internet connections depended almost entirely on cables. Ethernet cables connected computers directly to routers and network switches. The connection was reliable, but it wasn't flexible. Want internet in another room? Run another cable. Want to move your computer? Move the cable too. Engineers knew there had to be a better solution. Throughout the 1990s, several companies experimented with wireless networking. The challenge was enormous. How do you send data through the air quickly, reliably, and safely? Eventually, the IEE developed a standard called 802.11, and this standard would become the foundation of every Wi-Fi network we use today. The first versions weren't very impressive, but they laid the groundwork for a wireless revolution. And in 1999, that revolution officially began. Welcome to Wi-Fi 1. Officially known as 802.11b, released in 1999. Maximum speed, 11 megabits per second. Today, that's incredibly slow. But at the time, it felt futuristic. For the first time, people could access the internet without plugging in a cable. Laptops could move freely. Businesses could reduce wiring costs. Wireless networking suddenly became practical. But there was a problem. Wi-Fi 1 operated on the 2.4 GHz frequency band. Unfortunately, lots of other devices used the same frequency. Microwave ovens, cordless phones, baby monitors, even some wireless cameras. The result? Interference, dropped connections, and inconsistent speeds. Still, despite its flaws, Wi-Fi 1 proved one thing. Wireless internet was possible. The world wanted more, and engineers immediately started looking for a better solution. In the same year, another version appeared. Wi-Fi 2, also known as 802.11a. This version made a bold move. Instead of using 2.4 GHz, it switched to 5 GHz. That decision solved a major problem: less interference, cleaner signals, and much faster speeds, up to 54 megabits per second, almost 5 times faster than Wi-Fi 1. Sounds like a huge success, right? Not exactly. Higher frequencies have a weakness. They don't travel as far, and they struggle to pass through walls. So while Wi-Fi 2 was technically better, it wasn't practical for many homes. Consumers largely ignored it. Businesses adopted it. But mainstream users waited for something better. And that better solution arrived in 2003. If Wi-Fi had a breakthrough moment, this was it. Wi-Fi 3 combined the best parts of earlier generations. It used the long-range 2.4 GHz band, but delivered speeds comparable to Wi-Fi 2, up to 54 megabits per second. Suddenly, people didn't have to choose between speed and coverage. They could have both. This generation exploded in popularity. Homes began installing wireless routers everywhere. Coffee shops started offering internet access. Universities expanded wireless networks. Public Wi-Fi became a thing. For many people, Wi-Fi 3 was their first real wireless experience. But a new challenge was emerging. More devices were connecting, and Wi-Fi needed another major upgrade. By the late 2000s, internet usage was changing dramatically. Video streaming was growing. Online gaming was booming. Multiple devices were sharing a single connection. The old Wi-Fi standards couldn't keep up. Then Wi-Fi 4 arrived, and it changed everything. Its biggest innovation? MIMO. Multiple input, multiple output. Instead of using a single antenna to transmit data, routers could use multiple antennas simultaneously. Think of it like opening several lanes on a highway instead of forcing all traffic into one lane. Data moved faster. Coverage improved. Reliability increased. Wi-Fi 4 also introduced dual-band support. Routers could use both 2.4 GHz and 5 GHz. For the first time, users had real flexibility. Maximum speeds eventually reached hundreds of megabits per second. Wi-Fi was no longer just convenient. It was becoming powerful. But another leap was coming, one that would finally break the gigabit barrier. In 2013, Wi-Fi 5 arrived, and suddenly the internet felt faster than ever. This generation focused heavily on the 5 GHz band. It introduced wider channels, more advanced modulation, and improved antenna technologies. But two features changed everything. The first was beamforming. Instead of broadcasting signals equally in all directions, routers could focus signals toward connected devices. Imagine replacing a lantern with a flashlight. The second innovation was MU-MIMO, multi-user MIMO. Instead of serving one device at a time, routers could communicate with multiple devices simultaneously. This was critical because homes were changing. Phones, tablets, laptops, smart TVs, game consoles, everything wanted Wi-Fi. And Wi-Fi 5 handled it. For the first time, gigabit wireless speeds became achievable. 4K streaming became realistic. Large downloads became faster. The wireless future was arriving. But the number of connected devices was about to explode, and Wi-Fi needed to evolve again. Think about your home today. Smartphones, smart TVs, smart speakers, smart cameras, smart appliances. Some homes now have dozens of connected devices. That's exactly why Wi-Fi 6 was created. Speed improved, but efficiency became the real focus. The star feature was OFDMA. Without getting overly technical, OFDMA allows a router to serve many devices during the same transmission. Instead of waiting in line, devices can be served together. The result? Lower latency, better responsiveness, less congestion, especially in crowded environments. Apartment buildings, schools, airports, offices. Wi-Fi 6 wasn't just faster, it was smarter, and it prepared networks for a world full of connected devices. But there was still one remaining issue: spectrum congestion. That's where Wi-Fi 6E enters the story. Imagine a city where every highway is packed with traffic. Now imagine building an entirely new highway beside it. That's essentially what Wi-Fi 6E did. It introduced access to the 6 GHz band. For compatible devices, this meant dramatically less congestion, cleaner channels, lower latency, and more available bandwidth. The technology itself remained similar to Wi-Fi 6, but the new spectrum created breathing room, especially for demanding applications like 4K video conferencing, cloud gaming, virtual reality, augmented reality. The future was becoming clearer. But Wi-Fi engineers weren't finished yet. Not even close. Now we arrive at the latest generation, Wi-Fi 7. And this is where things become truly impressive. Maximum theoretical speeds can reach around 46 gigabits per second. That's multiple times faster than many wired connections. But raw speed isn't the most exciting feature. The real breakthrough is multi-link operation, or MLO. Previous Wi-Fi generations typically used one band at a time. Wi-Fi 7 can combine multiple bands simultaneously, 2.4 GHz, 5 GHz, and 6 GHz, at the same time. Imagine driving on 3 highways simultaneously instead of one. That's essentially what Wi-Fi 7 is doing with data. The benefits are enormous: higher speeds, lower latency, more stable connections, better performance under heavy loads. Wi-Fi 7 is designed for technologies that are just beginning to emerge: 8K streaming, cloud gaming, AI-powered applications, virtual reality, mixed reality, and future devices we haven't even imagined yet. Looking back, it's incredible how far Wi-Fi has come. From 11 megabits per second in 1999 to tens of gigabits per second today. Every generation solved a problem. Wi-Fi 1 introduced wireless networking. Wi-Fi 2 increased speed. Wi-Fi 3 brought wireless internet to the masses. Wi-Fi 4 improved coverage and performance. Wi-Fi 5 enabled gigabit networking. Wi-Fi 6 conquered device congestion. Wi-Fi 6E unlocked new spectrum. And Wi-Fi 7 is redefining what's possible. The next time you connect your phone, laptop, TV, or smart home devices to Wi-Fi, remember, you're using the result of more than 2 decades of engineering innovation. And the story isn't over yet, because the next generation of Wi-Fi is already being developed. The question is, how fast will wireless internet become in the next decade? Let me know your prediction in the comments. And if you enjoyed this complete guide, subscribe for more technology deep dives. Thanks for watching.